Hi, I am Tony Gong. Welcome to Weekend's Machine Epic column. All the design drawings are based on ideal conditions, but any manufacturing processes will have errors. So product designer must take manufacturing tolerances into account for their products. Many product development engineers struggle with the choice between manufacturing tolerances and cost. And in this video, I'm going to show you how to consider a suitable and low-cost manufacturing tolerances for your product manufacturing. For any product parts, the dimension tolerance of the part is usually marked when drawing the engineering drawing. These tolerances usually including the dimensions of the main feature of the part, which we generally call linear dimension tolerances. The actual shapes or relative projections of the points, lines, and surfaces that constitute the geometric features of the parts will differ from the ideal geometric shapes and relative projections specified by the ideal geometric bodies. These differences are collectively referred to as geometric tolerances, including the common ones such as flatness, perpendicularity, and projectional accuracy. Additionally, drawings must also specify tolerances for the assembly relationships between the parts, such as the hole shaft tolerances. So what is a standard that is usually referred to regarding the selection of tolerance classes? In the current international standard system, standard ISO 286 divides the tolerance range into 20 grades from IT01 to IT18. When selecting the tolerances grades, designers need to consider common part application. This is a table with the common parts applications for different tolerances grades. Additionally, to avoid the situation where the products are designed but cannot be manufactured, tolerance grades should be also determined based on the capability of various manufacturing processes to achieve the corresponding tolerance levels. This table corresponds to common machining processes and machining accuracy, including the tolerance levels that can be achieved by various machining processes, such as CNC milling, turning, grinding, etc. In terms of inspection, it is also important to fully consider the detectability of the tolerances when creating drawings. Common dimensional tolerance can be measured by using tools such as the caliper and micrometer, while more demanding geometry tolerances requires inspection with the CMM or OMM. Common fit tolerances such as the precising holes are inspected by using the gauge and the blocks. Before production begins, the manufacturing engineer needs to review the information on the drawings, including the material structure, dimension, and tolerance, etc. Because the type of the material, the part structure, and the tolerance requirements all have an impact on each other. The machining engineer needs to review each one individually to ensure that they meet the requirements specified in the drawings. Product drawings are not equivalent to process drawings for batch manufacturing. Design tolerances need to be converted to manufacturing tolerances. Here I take this collector part as a reference to show you how we went from drawing to manufacturing. This part is a wide-body collector made out of aluminum 2024. This is a high-strength aluminum which has good machining and cutting performance. However, this part needs to be turned over several times, resulting in accumulated errors. We focus on controlling several processes. One aspect is the geometry tolerance and the thread holes and other dimensions with tolerance. Another aspect is the surface finish of the wide body fitting surfaces. First of all, we need to analyze the 3D model, the part structure with multiple faces and matching shaft and holes. We selected the process of turning plus milling, divided it into 5 processes. For this collector part, we will make a process inspection guidebook. We will indicate the tolerances that need to be controlled in each process, step by step, and finally achieve the tolerance required by the product drawings. Before the formal production, in order to verify that the machining process meets the tolerance requirements, the first piece of trial production is required. After the first piece is completed, it will be sent to the quality department for testing and FAI report. Generally, the first piece will be tested in full size. After the FAI report confirms the trail processes meet the requirements, it is still necessary to control the dimensional stability during the formal and mass production processes. In this case, the quality engineer needs to develop a control plan and monitor it during the IPQC inspections to ensure that the tolerance for each process are under control. So, where should you start when considering appropriate and cost-effective manufacturing tolerances for your product? If you are a designer, this is a very good and professional question. Many designers, due to lack of the manufacturing experiences, when they design the tolerance, they often choose very high tolerances to make sure the design reliability, but ignore the process and the cost. In general, from the economic perspective, it is not the highest possible dimensional accuracy of your product. The quality is better, nor it is the more advanced processing equipment your product is more competitive. Control the tolerance range under the premise of ensuring the performance and the life of the product. The tolerance range should be expanded as far as possible, especially for the parts with high precision requirements, because the size of the tolerance range is not an ordinary algebraic relationship with the difficulty and cost of the process. It is often the growth of the geometric level. First, define the functional requirements of the parts in assembly and work, and determine which dimensions and features are critical to product performance, quality, and reliability. For key functional parts, small tolerances should be given to ensure the accuracy. For non-critical parts, tolerance can be appropriately relaxed. Secondly, you need to choose the economical manufacturing process as possible for your product. Evaluate the manufacturing process capability and understand the precise level and the repeatability of the manufacturing process used. According to the process capability, to determine a reasonable tolerance range to avoid setting too strict tolerance resulting in high processing costs or difficult to achieve. To avoid too wide tolerance affecting the product quality. Finally, for mass production, to reduce the unnecessary tolerance measurement cost and improve the production efficiency, you need to also develop a reasonable dimensional inspection plan, control the important and critical dimensions, and determine a reasonable sampling quantity. Thank you for watching. We hope this video has provided some help with your product manufacturing tolerance design. You can also contact Wickens manufacturing team for direct assistance. See you in the next episode for more exciting content.